Patrick from the Backyard Science Lab, and today I'm going to be doing another video on vacuum chambers. This was one of my favorite experiments to do, the last one that we did, which was unboxing the Action Out subscription box. That should, hopefully if I remember, be in an iCard in the upper right corner. Okay, and so the first thing I want to do from last time is I used warm water to do the cold boiling experiment. So this time I want to use hot water. This was also a comment, although I already had this video planned. This was also a comment. Hopefully I remember to type his name in a corner somewhere. And I want to see if using hotter water, because last time, if you didn't see it, I couldn't get it boiling with warm water. And now my theory on this is that just like how on Mount Everest, the air is so much thinner that when you boil water, you can do it at a much lower temperature. Now, if come up, you can see the vacuum gauge here. You can see as it goes up, and the vacuum chamber. It's not doing much, and it probably won't do much. So on Mount Everest, it takes a lower temperature to boil water, and I don't know what exactly. I don't know what exactly, but my theory is that the lower it gets, the lower the temperature reading is. So, that with my 25 negative PSI, I think this is counting in. Yeah, hopefully. I should be able to get something. Going slower once I hit that good boil. Oh, you can see it come boiling, and it suddenly starts to boil. And now you can, if there's any experts on this, you can tell me in the comments, but is this actually cold boiling or is it degassing? And that's one thing I was wondering when I was testing out this video, because one thing that's interesting is if I leave this for a while, it stops. And I first thought this was because of the steam, and you can actually see all of my pipes steaming up because of the steam from the water that's boiling. Although, you can start to see it slowing down. Although you can see my PSI gauge is really not changing. So I'm not sure if, if there's any experts, maybe you could tell me, because I'm not an expert. But if this is actually boiling or degassing, and when this is slowing down, I have been just degassing all the gas out of this. Okay. No, I think that's about as much as we can do. And now I'm going to fill this again, but using ice cubes. And now this is this is my main thing I want to test for today. These ice cubes, because there's two ideas I have for this. These have a lot of air pockets. And now a lot of the other things that we use that are air pockets, balloons, shaving cream, whatever, all exploded or expanded. So I want to see if these ice cubes will explode or expand. Second, if this boiled, now I don't think it's actually getting hotter, but if this boiled, would that mean that this ice cube would melt faster? I don't know, we'll see. So I will reset this vacuum chamber to when I have my ice in it. Okay, so we're back, and I'm going to put my ice cubes in here. I completely cooled the chamber with cold water, so it should not melt the ice cubes quicker. Also, I dried it out to the best of my ability. And now, does this fit? It's going to be hard getting out. No. I may crack that up into smaller pieces, but I want to try a bigger ice cube. Although I think we'll just attach this. And now again, my contradicting things are, one, will the air pockets make it explode? Now I'm not sure about this one, because ice is much harder than rubber and stuff that I use for the balloons, the foam and stuff, and the marshmallows. So I'm not sure if it's actually going to explode. Although will it melt? I'm not sure either. because, yeah. So, as always, hopefully you can see the pressure gauge in the pressure gauge there with the vacuum chamber. Taking a while to pump up. So, I see maybe, so they're definitely not exploding. I see some glassy stuff on them. I'm not sure if that's just the, if that's water melting faster, if that's just a little tiny bit of water that was there before. I do see, actually, from the water that's forming below, I saw a bubble earlier. Actually, let me turn you on to this side. I'm not sure if you can see it on that one. There seems to be some, yeah, looks like I've been able to see it from here, are what looks like some bubbles rising out of it. I'm at almost -25, which is just about 0.8 atmospheres. But I do see some bubbles. But I think that's about the most as we're going to get out of this. So I think I'm going to depressurize this. I don't have any efficient way of depressurizing this. Okay, there we go. There we go. If you didn't know, I cannot actually, let me try this. I cannot actually unscrew the cap while it's vacuumed because of the force of the vacuum pulling on it. So it is actually a lot of water in here. I'm not sure if it actually went quicker. I may want to test that. They feel, I don't know why I'm doing this, but you know, it actually feels kind of rough. And I wonder if that's because the top layer of the ice was melting away so that the little pockets of bubbles were only coming away and it wasn't melting evenly. And it's actually amazing how rough some of these are. Some of them are almost uniformly bumped. And I don't think that was anything to do with the vacuum chamber. So that is interesting. So I am going to break this up and see if we get any different result with this bigger ice cube. Okay guys, I broke this apart and we'll see if they'll fit in here. So I want to see if there's any difference with this because these are all very, very smooth, uniform pieces. And so I want to test this again to see if there'll be any change from the bigger ones. Now from the other ones, I really thought there'd be a better reaction. So I want to look at this to see. They do look like they're melting. You know, I might leave different ice cubes in here and see if they melt the same. The same way. Okay. Yep, this isn't looking to be very different. That's normal. We didn't lose pressure. Okay, so we're at 25 atmospheres, and I don't see any, or 25, -25. Oh my god, that's like 0.8 atmospheres. Okay, So actually, I do want to try this now to try to unscrew this. I'm going to need a paper towel to try to get retraction on this, because this is kind of an interesting thing. So because of the vacuum in here that's pulling everything in, it's also pulling this cap in. And so it should be harder to... I should make this like a test, set up like a booth somewhere. Ugh. No, this is not budging. Although it's easier for me to unhook this part, and even this is harder. But it's easier to unhook it because it's a smaller surface area. So now you can see how easy it is to unscrew this. Now. Okay. They do, again, feel very rougher, and I know there's no way to actually prove this scientifically. But, yeah. See if I can get close-ups of it, but I'll look through this footage to see if I could slow it down or anything, but no, they all seem pretty much, except there was one side on this and one side on this one that had weird uniform bumps. I'll see if you guys can see it from that camera. Weird uniform bumps. I'm not sure if that's... I wish there was something I could like imprint this on. I'm not sure if that's from anything in here. Although that's very interesting. Okay guys, so our ice really didn't do as much as we expected, although our boiling water had a major reaction that made it viciously boiling. I'll see you next. Before you guys leave, I have to tell you about the Backyard Science Lab news. May 27th, that is Memorial Day, that Monday, I'm going to be live streaming a Falcon 9 launch. Also, if you would like to be in any of my videos, I know I just recently posted a bamboo bridge video with my friend Ethan. You can email me at thebackyardsciencelab@comcast.net. Next time in the Backyard Science Lab. Up there will be my channel, channel for you to subscribe. Up there will be my other vacuum chamber videos, and down there will be a video that YouTube has picked just for you.